In today's lecture, we will see that the internal structure of our Earth. What is this Earth? We all know that we are living on the surface of the Earth, but what is below this surface? So that is what we are going to discuss today. What is happening there? What is it composed of? So on screen, what you see is our beautiful Earth from the sky. And if I divide this, cut this Earth into equal halves, and if I see from one side what is it inside, then I am expected to see a three-layer structure. Okay, so this three-layer structure, which is having a radius of around 6,371 kilometers, and if you see the radius of the Earth, in the polar radius will be little lesser compared to the equatorial radius. Okay, it is something like it is flattened a little bit. So that is the shape of the Earth. But what we are talking right now, here it is 6,371 kilometers of average radius of our Earth. And the outermost layer of the Earth, we call it is the crust, that is indicated by this blue outer line. And the major portion of our Earth, which becomes around 82% of the total volume of our Earth, that is composed of, that is called a mantle. Okay, so the outermost layer we call it as the crust, and the second layer we call it as a mantle, and the third layer we call it as core. So if you cut the Earth into two equal halves, and if you see, it appears like a three-layer structure, and the three layers are crust, mantle, and core. Crust is the outermost one. On the surface of that we live. Mantle is the second layer, which becomes the major major volume of the Earth, and third one, which is the core of the Earth, and the radius of it is 6,371 kilometer average. And if you see the depth up to which the mantle and the core differentiates, that is at a depth of 2,900 kilometers. Fine. So this is a simple three-layer model of the Earth, but it is not that much simple what we see. If you go into this details, like what I have just discussed is basically on the composition of the Earth, it can be divided into three portions: crust, mantle, and core. And the crust, the thickness, which is around 7 kilometer to 70 kilometer, it varies because on some part of the crust or the outer part, we will have a land or a continental portion, and in some part of the crust, the surface, what we have a oceanic portion. And the oceanic portion, the thickness of the crust is less compared to the continental portion. So if you go to the Himalaya, where the maximum thickness what we get, which will be much thicker than compared to a oceanic crustal part. And to the second layer, it is the mantle, and the third layer, it is the core. So if you go to the detailed physical properties of these layers, the outer portion of the portion of our Earth, that is the crust, we divide it into two parts. It is a continental crust and a oceanic crust. And the mantle, we are able to divide it further into two portions, that is upper mantle and the lower mantle. Okay, so the upper mantle and the lower mantle, then the core is also able to divide it into two parts, the outer core and the inner core. And if you see the physical characteristics of these layers, it varies somehow. So that is identified, these different layers by which these different layers are identified by different scientists accordingly, where there is a change in the property and the contact between two different layers, we identify it is a discontinuity. We call it as a discontinuity. For example, the first layer is a crust, and after that there is a mantle. So there is a discontinuity between the mantle and the crust, which changes in properties of materials over there. So that is identified by a scientist called Mohorovic. So that discontinuity, that is marked A here. Yeah, outer part what we see, it is a continental part, and then it is the this is the crust, then it is the mantle. In between there is a discontinuity. That discontinuity is an average depth is given 35. As I said, it varies from 7 kilometer to 70 kilometer, but for the understanding we consider it is an average depth of 35 kilometers, and that is called a Mohorovičić. It is pronounced as Mohorovičić discontinuity. Similarly, if you go further down, this is the mantle, this is upper mantle and the lower mantle, and if you go continuously down, we will reach a point where there is a change in the properties of material, and that property or that discontinuity is known as Gutenberg discontinuity, which marks the boundary between mantle and core. Mantle and outer core, in fact, in detail, mantle and the outer core. And if you go further down, there is one more discontinuity which differentiates between the outer core and the inner core, that is called a Lehmann-Bullen discontinuity. So our earth is divided into different layers. Basic 3-layer model: crust, mantle and core. Crust and mantle is differentiated by a discontinuity is called a Mohorovičić discontinuity. It varies a thickness from 7 kilometer to 70 kilometers. The depth of the discontinuity between mantle and core is called Gutenberg discontinuity, which is at a depth of around 2900 kilometers. And further down below, the discontinuity which separates the outer core and the inner core is called a Lehmann-Bullen discontinuity, which is at around a depth of 5100 or 1200 nearly. 5155 is written here, that much depth below the surface. Correct? So this is what the internal structure of our earth. A simple 3-layer model, but we are not going into any further details. And if you see the characteristics of these layers, the outermost crust is solid in nature. It's made up of solid rocks. And if you go to the mantle is also seems a solid in nature, and the outer core which is liquid in nature, and the inner core which is solid in nature. Ideally speaking, at a depth and the center of the core at a very high temperature, it is not possible for any matter to remain in solid state because of the temperature. It goes around 4400 degrees Celsius temperature at the center of the earth, that is what we assume. That is not possible for any material to remain in solid state, but it becomes, or it appears like a solid material because of the high pressure on this part. Okay, so all this high pressure which make the materials, even if it is having a liquid nature, because of the high pressure it consolidates and it appears like a solid. Okay, so hope these things are clear now. 3-layer model of the earth, and which is differentiated or identified or separated by different discontinuities. Correct? Okay, so now let us start discussing it one by one. As I said, first layer of the surface of earth, it is crust. The thickness of the crust varies in different parts. In mountain areas, which varies from 50 to 60 kilometer. Like if you see here, this is the hilly terrain where the thickness of the crust is maximum. As it goes much higher, the same amount it goes down, so it becomes the maximum thickness in the hilly regions or the mountain regions, and in other parts it is from 30 to 40 kilometers in variation, whereas in the case of oceanic crust, which is at a depth or thickness of 5 to 19 kilometers. Okay, so this continental crustal part, if you see this 70 kilometer average, around 70 kilometer part of this continental part, that we can divide into 3 different layers. Okay, so these 3 different layers are the uppermost layer on the surface, which becomes a sedimentary layer, a loose materials or a deposit by the agents, natural agents. Then there is a granite layer. Then there is a basalt layer. Don't worry, granite and basalt are terminologies used to represent rocks. Granite you will be aware of. We'll study the details in igneous petrology in later part. But right now, Just understand the granite layer and the basalt layer are there in the continental crust. So that becomes the three-layer model of the continental crust, and in between the granites and the basaltic layer in the continental part, we have another small discontinuity at around 11 kilometer that we call it as a Conrad discontinuity. Okay, so this is the nature of our continental landform. Similarly, if you go to the oceanic landform where all these different layers are missing, this upper sedimentary layer and granite layers are missing. Granite layer is missing, so upper sedimentary layer may be there, and it is basically composed of a basaltic layer. And when it is made up of basaltic layer, the major composition of chemical composition I'm talking about, it is silicon and magnesium. Whereas in this case, in the granitic layer, the major composition is silicon and aluminium. So that the oceanic crust where the basaltic composition is more is called a SIMA, S-I-M-A, silicon, magnesium, and the granitic layer which is called a Sial, which is silicon and aluminium. Okay, so you must have heard about something like lithosphere. Okay, lithosphere is a thickness of around 100 kilometer, which includes the total crust portion and some part of our upper mantle. This together we call it as the lithosphere. The plate tectonic theory, the concept of plate tectonics or the movement of plates, the lithospheric plate is moving. That means it is moving including the crust portion and some upper portion of the mantle, which is separated by a plastic low velocity. Low velocity is the seismic velocity which is written here, but it is a plastic layer above which it acts as a lubricant for this upper lithosphere to move over this mantle. Okay, so the layer which goes up to upper mantle goes up to here and the crust goes up to here, but these two things together above the asthenosphere, the plastic medium above which the lithosphere is moving, which includes upper portion of the mantle and the continental crust together. Some places, if you see the lithosphere, it may only have continental crust. Some base it will only have oceanic crust. Some plates which will have some lithospheric plates which will have oceanic and continental parts together. So these all three different combinations are possible. This is what our details of our crust. So crust is divided into continental crust and the oceanic crust, and the thickness of these layers are different in oceanic and continental part, and the composition of these layers are also different. As in the case of continental crust, we have upper sedimentary layer, granite layer, and a basaltic layer, whereas in the case of oceanic crust, the granitic layer may be missing, and it will be basically composed of a basaltic layer. So the chemical composition is represented by SIMA. SIMA indicates silicon and magnesium, and Cl indicates silicon and aluminium. And in the continental part, which is separated by a discontinuity, that is called a Conrad discontinuity at around 11 kilometer below the surface. Right. So this is about the crust. Now next is about the mantle. Okay, so as we all discussed already, the second layer of the earth, the mantle, which is separated from the core at a depth of 2900 kilometer, and the upper portion of the mantle, we call it as an upper mantle, and this upper mantle includes different things. As we already discussed, it includes asthenosphere, it becomes a part of the lithosphere, and this both the upper mantle and the lower mantle both remains in solid state, and most of our volcanic activities, you know that the volcanoes are erupting, so volcanic activities are mostly erupting from the upper mantle region. So there are, we call it is magma plumes, where there is a reduction in the pressure. The materials here will have a tendency to loosen their strength, and it's starting moving towards the upper part or towards the surface, and it creates the eruption through some volcanic necks. So we call it as a volcano. So most of that things start erupting from this upper part. So this is divided into two parts. We are really not very much aware about that what exact characteristics of this mantle. Still, the researches are going on, but we have a general idea that how this mantle behaves and how this chemical composition is and what its general characteristics are. And we have discussed about asthenosphere. It is a 100 to 150 kilometer depth plastic layer. Okay, above which what we call it is a above the asthenosphere we call it as a lithosphere. Okay, it includes the part of crust and some part of the mantle. That becomes the lithosphere. So next is the core. As we discussed that the core is in the central portion, where inner core and the outer core. Inner core is in solid state and the outer core which is in liquid stage, and the chemical composition is basically nickel and iron. Basically it's composed of nickel and iron, and the movement of this nickel or metallic iron in the outer core, that is the reason for our magnetism, the earth magnetism, and that movement varies and there are changes in the earth magnetic field also.